Today we're going to be going through some of the hyperbolic trig identities. So, for just starting off, these are the definitions of all the hyperbolic trig functions. So, sinh of x, e to the x minus e to the negative x over 2. Cosh of x equals e to the x plus e to the negative x over 2. And the rest you can read. They're based off of the regular trigonometric functions. For example, tanh of x is sinh of x divided by cosh of x. Likewise, tan of x is sine of x divided by cos of x. So the first identity I wanted to start off with is just showing that they are even. I'm showing that sinh of x is odd and cosh of x is even, rather. So, as we can see, sinh of negative x is e to the negative x minus e to the x over 2. And this is just flipping the subtraction from e to the x minus e to the negative x over 2. So clearly this is negative sinh of x. So sinh of x is odd. Moreover, cosh of negative x equals e to the negative x plus e to the x. And this is just cosh of x because you're flipping the addition instead of the subtraction. Okay. Next thing I'll put up just because I think it could help us out for the next couple of identities. We're going to be doing some square identities for these. So the first one is cosh of x plus sinh of x. So we just take the definitions here, e to the x plus e to the negative x over 2, and we add that to e to the x minus negative e to the negative x divided by 2. And this is, you add e to the x and e to the x, but you subtract e to the negative x from e to the negative x. So you get 2 times e to the x over 2, so that's e to the x. And then cosh of x minus sinh of x, because as we can see, cosh is even and sinh is odd. We can change cosh of x into cosh of negative x and sinh of x into positive sinh of negative x, which is equal to e to the negative x. And we're going to use this fact to show the cosh squared, sinh squared identity very simply. So rather than going to the definitions for these and squaring them, we're just going to use the difference of squares to factor cosh squared x minus sinh squared x into cosh x plus sinh x times cosh x minus sinh x, which we've shown is equal to e to the x and e to the negative x. When we multiply those together, you get 1. And in turn, this implies we're just going to divide both sides by cosh of x with this fact that cosh squared x minus sinh squared x equals 1. We're going to divide both sides by cosh of x. So, we're going to divide both sides by cosh squared of x. So we get 1 minus tan squared x, because cosh squared x divided by cosh squared x equals 1, and sinh squared x divided by cosh squared x equals tan squared x. This is equal to sec squared x. That's 1 over cosh squared x. Therefore, sec squared x plus tan squared x equals 1. And finally, we're going to do something similar, dividing both sides by sinh squared x. So you get, when you divide cos squared x and sinh squared x, coth squared x minus 1, because that's sinh squared x divided by sinh squared x. And 1 over sinh squared x is cosec squared x. And that means that coth squared x minus cosec squared x equals 1. All right, that's part 1 of the hyperbolic trig identities. Most of these focused on the basics and the square identities. Next episode is going to devote to some of the double angle formulas for hyperbolic trigonometric functions. That's it. Thanks for watching.